Good morning. I am Narmatha, Assistant Professor, Department of Cybersecurity, working in Dr. S.N.S. Rajlakshmi College of Arts and Science. In today's lecture, we are going to discuss about deadlock detection and recovery. So, in detection, we have resource allocation graph, wait for graph, and algorithms. In deadlock recovery, we have three things: selecting a victim, rollback, and starvation. So, we'll see one by one. Deadlock detection. If a system does not employ either a deadlock prevention or a deadlock avoidance algorithm, then a deadlock situation may occur. In this environment, the system must provide an algorithm that examines the state of the system to determine whether a deadlock has occurred. An algorithm to recover from the deadlock is given. So, a single instance of each resource type. Maintain wait for graph. So nodes are processed. Here we are representing the nodes and directions. So nodes, we can call it as a process. Periodically it invokes an algorithm that searches for a cycle on the graph. If there is a cycle, there exists a deadlock. An algorithm to detect a cycle in a graph requires an order of n squared operations, where n is the number of vertices in the graph. So resource allocation graph is represented here. So the first picture, it represents resource allocation graph, and second one, it represents wait for graph. So any circle is there, so that represents a deadlock. So we need to remove that circle form. Several instances of a resource type. So here we need to check availability, allocation, and request. Available means a vector of length m indicates the number of available resources of each type. Allocation, n into m matrix, it defines the number of resources of each type currently allocated to each process. And request, n into m matrix, indicates the current request of each process. If request ij is equals k, then process pi is requesting to more instance of resource type rj. Detection algorithm usage. When and how often to invoke depends on how often a deadlock is likely to occur, how many processes will need to be rolled back, one for each disjoint cycle. If detection algorithm is invoked arbitrarily, there may be many cycles in the resource graph, and so we would not be able to tell which of the many deadlocked process caused the deadlock. Recovery from deadlock. So here we have different kind of things. Process termination. To eliminate deadlocks by aborting a process, we use one of two methods. First one, abort all deadlock the process. It breaks the deadlock cycle, but at great expense. The deadlocked process may have computed for a long time, and the result of these partial computation must be discarded and probably will have to be recomputed later. Second one, abort one process at a time until the deadlock cycle is eliminated. After each process is aborted, a deadlock detection algorithm must be invoked to determine whether any process are still deadlocked. Aborting a process may not be easy if the process was in the midst of updating a file. Terminating it will leave the that file in an incorrect state. Similarly, if the process was in the midst of printing data on a printer, the system must reset the printer to a correct state before printing the next job. So if the partial termination method is used, then we must determine which deadlock process should be terminated. This determination is a policy decision similar to CPU scheduling decisions, in which order should we choose to abort. Priority of the process, how long process have computed and how much longer to completion. Resource the process has used, resources process needs to complete, how many processes will need to be terminated, is process interactive or batch. So by using all these considerations, we have to choose a portion of a particular process to avoid a deadlock. Resource recovery by using resource preemption. If preemption is required to deal with deadlock, then three issues need to be addressed: selecting a victim, rollback, starvation. Selecting a victim, it minimizes the cost. Rollback, it return to some safe state, restart process for that state. Starvation, Same process may always be picked as victim, including number of rollback in cost factor. From this lecture, you can understand about the concept of deadlock recovery. So we have used different algorithms and recovery functions. By using that, we can recover from deadlocks. Thank you.